in this topic, we'll talk about molecular polarity. We learned about polarity when we talked about electronegativity, when we were talking about periodic trends. So if you remember a bond between HCl, the electronegativity of this is 2.1 and this is 3.5. So there is a big difference. Is the difference greater than 0.5? So equal or greater than 0.5 is polar. So I said this bond is polar, this is partial negative, this is partial positive. So that's what is called molecular polarity. The molecule is polar because it has a positive pole and it has a negative pole. So based on this, we will talk about molecular polarity in terms of shape as well. So the molecular polarity I just discussed here is the basically I call it bond polarity. Is this bond polar or non-polar? But molecular polarity is different thing. Remember, do you remember shapes? We learned about shapes. 5 different shapes. We have linear. We have trigonoplanar. We have trigonopyramidal. We have bent and tetrahedral. Okay, out of these shapes, this is 3, 4, and 5. Now listen to me carefully. That out of these 5 shapes, the 3 shapes, 1, 2, and 3, linear, trigonoplanar, and tetrahedral. These 3 shapes are symmetrical. When the molecule has this shape, even if the bond is polar, molecule will be non-polar. Okay, keep that in mind. Even if the bond is polar, molecule is non-polar. But the other 2 shapes, which is trigonopyramidal and bent, even if the bond is not polar, they will always be polar. So, bottom line is that molecular polarity can overrule the bond polarity. That's what I'm telling you here. That molecular polarity can overrule bond polarity. And how? I repeat it. We have 5 shapes. Once you decide what is the shape of the molecule based on the dot diagram, if the shape is linear, trigonoplanar, or tetrahedral, the molecule is going to be non-polar even if the bond is polar. Alright? But if the shape is between these 2, the pyramidal and the bent, the molecule is going to be polar even if the bond is not polar. But I will explain what I'm saying here. Can I move on? As an example, let's talk about CCl4. So we first of all need to do the dot diagram of CCl4. I'm going to remind you how to do the dot diagram. We are supposed to count the valence electrons. 4 chlorines bring in 28. So it's 32. You always divide by 2. It is 16 pairs. Right? So if you have 16 pairs, if carbon is there, carbon is the central atom. I'm using 4 pairs to make 4 bonds with 4 chlorines. So out of 16, I used 4 pairs. I'm left with 12 pairs. Carbon already has 8 electrons around it. 2, 4, 6, 8. Carbon has 8. I don't need to work with carbon anymore because carbon has 8 already around it. But chlorine doesn't have 8. So I'm going to give rest of the pairs. I have 12 pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I used the 12 pairs to make sure each chlorine has 8 electrons around it. I used all my 16 pairs. So after this, how many bond pairs do I have on the central atom? So this is called dot diagram. If you remember, this is called dot diagram. or Lewis dot diagram, because time to review, so make sure you understand the difference. Now if I ask you to write down the geometry, what is the shape of this? How do we decide what is the shape of this? I look at my central atom and I find out how many bond pairs and lone pairs it has. So my central atom has 4 bond pairs and 0 lone pairs. If a central atom has 4 bond pairs and 0 lone pairs, the shape is going to be tetrahedral. Okay, if I look at the electronegativity now, alright, the electronegativity for carbon is 2.5 and chlorine is 3.5. So the difference between the two is 1.0, which is greater than 0.5. That makes the bond is polar. So if the bond is polar, each chlorine is partial negative and carbon is partial positive, right? This is based on bond polarity. So for this molecule, bond is polar. Do you understand how the bond is polar? Okay, but the shape is tetrahedral. And on the back page, I told you that if the shape is tetrahedral, or trigonoplanar, or linear, the bond is always non-polar. The molecule is always non-polar. So going back, bond is polar, but the molecule is non-polar because of the shape. Because it's a tetrahedral shape, which is a symmetrical shape. So the molecule is non-polar. So molecule can overrule the bond polarity. Am I clear with this? The molecule can overrule the bond polarity. So for each compound on the next page, you need to tell me if the bond is polar or non-polar. That is based on electronegativity difference, greater than 0.5 and or smaller than 0.5. And then molecular polarity depends on the shape. Alright, let's do another example. CO2. This is a linear shape. The bond is polar because this is partial negative and this is partial positive. So in this situation also, bond is polar. How do you know bond is polar? You go to electronegativity chart. This is 3.5. No, it is not 3.5. It is something different. I don't remember exactly. You have it on your papers. You have the electronegativity chart on the paper somewhere. Yeah, here it is. So oxygen is 3.5. Okay, chlorine is 3.0. Oxygen is okay. So it is 3.5. So this is 3.5 and this is 2.5. So this difference is 0. That makes the bond polar. But the molecule is non-polar because it is linear shape. And linear shape is a symmetrical shape. So one more time, I'm going to rewrite it. What are the symmetrical shapes? Linear, trigonoplanar, and what else? Tetrahedral. So these three will always be non-polar. Okay? And now bent and trigonopyramidal will always be polar. So let's do the dot diagram, do the shape on the next page, that is practice page, and tell me if the bond is polar based on negativity, and then if the molecule is polar or non-polar based on shape. I still have to cover the intermolecular forces, which I will do in a few minutes once you complete the practice.